So in the graphing calculator, let's review how to graph things. First, you need to go to y equals, that's the button on the top left. Clear out anything that's in there. And it also says in the notes, right here, step 2, look at the top of the screen, make sure all the plots are off. Make sure plot 1, plot 2, and plot 3 are not shaded because that will totally screw up your graphs. In y1, enter the first function. Remember that x is that button that says xt weird 0n. And if your graph ever looks funny, you can use step 4, zoom, and then select number 6. That resets your graph to -10 to 10, -10 to 10. So just keep that in mind. If you ever want to make sure your graph is normal, push zoom 6. So we're going to enter the parent function. A parent function is the simplest type of that particular function. So quadratic functions involve x squared. The simplest equation that we can look at involving x squared is plain old y equals x squared. So in y1, we're going to type in x squared, not log, x squared. Your square button is currently highlighted in red. It's diagonal up from the 7. It's easier than pushing the exponent button and then a 2. Okay, let's graph that and sketch a picture of that graph. Does anybody remember what this type of graph is called?
Quadratic.
It's quadratic.
Quadratic.
What's the shape called?
Parabola.
Parabola. Okay, remember that is parabola. Parabola is like some evil disease that's going to kill us all. We're not going to talk about awful diseases. We're going to talk about parabolas. Parabola. It is symmetrical. No, parabola is not something. There is a vertex at the bottom of that parabola, the spot where it switches from the left side switching to going back up on the right side. That spot is the vertex. Okay, we're going to leave this parent function in y1. So go back into y equals button and arrow down so that you're in y2 equals. In y2 equals, we are going to enter this function, parentheses, x minus 3 squared. So parentheses, x minus 3, close your parentheses, squared. Before you hit the graph button, I want you to think about what do you think is going to happen? It's going to move. Why do you think right 3? When we did absolute value graphs, anything that happened inside the bars with the x moved the graph side to side. And I told you then that the patterns that we were noticing were going to happen every time we looked at a graph. So if you're thinking right 3, you are correct. So grab or draw a little sketch of that. In my sketch, because I have colors, I am going to sketch both the blue and the red. I'm going to make myself a little note that it moved to the right. Describe how the graph differs from the original. It moved right 3. We should probably say translation left or right 3 units, but we can just say moved. Then it asks, what do you suppose would be different if instead we had done x plus 3 inside the parentheses? What do you think would happen? If minus 3 moved it right 3, what's plus 3 going to do? Left 3. Okay. All right, I want you to try step 3 on your own. You're going to go back into y equals, leave x squared in that first spot, go down to y2, clear it out, and you're going to plug in this h function, 2x squared, sketch the graph, describe how it's different. Then you'll delete that one and put in x squared plus 1, sketch the graph, describe how it's different. So try both of these on your own, get some pictures, see what you think the differences are. When you graph 2 times x squared, it makes a skinnier, more narrow, possibly steeper little parabola. That is called a vertical stretch. So you may want to write in there that this is a vertical stretch. I drew gray arrows looking like we're compressing it from the side to make it narrower, but really what's happening is you're grabbing the bottom and the top of it and you're stretching it vertically. And by stretching it, it's going to make it skinnier. If that had been a 1/2 instead of a 2, that would shrink it down vertically and make it wider. The +1 not in the parentheses for J moves the graph up 1 unit. If it had been a -1, that would move it down 1 unit. Okay, let's go to the next page and summarize this. So A times the quantity x minus h squared plus k. When you're writing these, you really need to be careful not to forget the square. A lot of people, if I ask you to write a function, you'll get the parentheses in there, but you forget the square. So don't forget the square. The A indicates a reflection and or a vertical stretch or shrink. So on the previous page, we looked at the stretches and the shrinks. It is a stretch if it's a number like 2, 3, 4, etc. It is a shrink if it's a number like 1/2, 1/4, or a decimal. The reflection, if A is positive, the graph is going to open up and be a U-shaped parabola. If A is negative, it's going to flip that graph down over the x-axis and it's going to look like a hill, an upside down U. It'll open down. So that positive or negative is going to tell us if the graph opens up or if the graph opens down. And if you want to see that, I can graph in here. Let's do -1/2 times x squared, so you can see, actually let's do -1/4 so you can see a really wide graph. So there's the original. Notice the red one is a lot wider because I used 1/4, and because of the negative it flips it down and it opens down instead of opening up. The H is the horizontal translation. Horizontal translation is always backwards, messed up, opposite of what you think it would be. So plus H moves to the left. It's so backwards that sometimes I even write it wrong. And minus H moves to the right. The number added or subtracted outside of the parentheses is normal up and down movement. So plus K moves up and minus K moves down. For the rest of the notes today and for your assignment, you can use the graphing calculator, but if you use this as a guide, you shouldn't have to use the graphing calculator. I want you to recognize the pieces of the function that are moving it and changing it so you don't have to put it in the graphing calculator every time. So A, describe the transformation. We're basically describing how is it different from f of x equals x squared. How is it different from plain old ordinary x squared? So in A, what does the +4 do? Left 4. And what does the -1 do? Down 1. And notice there isn't a number in front right here, so it's going to be a graph that opens up. It's going to be the same width as a normal graph. How about B? Right 3. Okay, C, there's a couple things happening in C. First of all, the negative. The negative is going to make it open down, so opens down. And then the 1/2 is going to make the graph wider. That's called a vertical shrink. Okay, D. Do you see something weird in D that we haven't talked about? And that 2 is inside the parentheses instead of outside of the parentheses. So normally a vertical stretch or a shrink is supposed to be outside of the parentheses, not inside. This actually indicates a horizontal stretch and shrink, which, to be honest, we're not going to use. So you can ignore D. We're going to skip that one. E, we're going to change. I'm going to rewrite this as g of x equals 5 times the quantity x plus 2 squared plus 4. Try E and F on your own. Pause the video. For E, the 5 is going to make the graph more narrow. That's called a vertical stretch. The plus 2 is going to move the graph left 2 units. And the plus 4 will move the graph up 4 units. In F, the negative is going to make the graph open down. Technically, that's called a reflection, but on the test or the quiz, I would say this graph opens and you'd have to select up or down. This means the graph's going to look something like that. The plus 3 moves the graph left 3, and the plus 2, wow, these two are almost identical, weren't they? Up 2. Okay, so now you're getting better at looking at the equation and describing how it looks. Now let's describe how it looks and write the equation. So in example 2a, we need to write a rule. We're starting in A with the equation x squared. So we're starting with x squared. We need to do a vertical stretch by a factor of 2. Anyone want to take a guess where we should stick that 2? Before the x. Then it says followed by a translation 3 units down. Up and down, does that go inside the parentheses or outside the parentheses? Outside the parentheses, so a minus 3. To make this your final answer, you just need to put g of x in front of it. It said in the directions, write a rule g, so that just means we're naming the new one g instead of f. Okay, B is similar, except we're not starting with just x squared. This time, we are starting with x squared minus 5. This graph is already 5 units down from the origin. Okay, first it says a translation 3 units right. Right and left has to happen inside a set of parentheses. So you put parentheses directly around the x, and we need to stick that 3 somewhere inside the parentheses. For right, do I use minus or plus? So we'd have x minus 3 in the parentheses. We still have the minus 5. Then it says 2 units up. What do we normally do for 2 units up? Plus 2, so stick a plus 2 at the end. Is there any simplification you think we could maybe do? Negative 5 plus 2 is negative 3. So we have x minus 3 squared minus 3. And if you think about this, this graph is down 5. We want to go 2 units up. So if you are currently, 1, 2, 3, 4, 5, if you're currently here and you want to move 3 units up, your result would be down, 2 units up. I can't count, can I? Oh my gosh. Thought I was doing so good there.